Regardless of the material you use to print your Astromech, there are a handful of parts that even though you can 3D print, you're probably better off replacing with off-the-shelf components or straight-up hardware. As I recently needed to do some repair work on my Mark III drives, I thought I'd post a quick summary of what I would consider to be the most essential mods for a Baddeley Mark III printed Astromech. Let's start with the center foot. The first change that I made from the stock Baddeley design was replace the 3D printed ankle joint with a 5/16 inch threaded rod. You can't use a bolt here because the foot shell needs to be able to slide over this entire assembly, so whatever you put in there needs to sit flush or just a little recessed. I was able to take the 5/16 rod, cut it down to a little over 2 1/4 inches in length, and Dremel in a little crosshair in there so that I can easily just use a Phillips head screwdriver and fit that in there. It will cut some threads, but it holds in there really, really well. And then let's talk a little bit about Vex Omni Wheels. Yes, this is an expensive modification. You can 3D print yours according to the Baddeley designs. But these are, in my opinion, such a fantastic upgrade. These things are rock solid. This is actually an older design of the frame. The newer design has little inserts at the top so you can lift the axles out as one assembly. But these actually take, I think it's an M8 steel rod with collars on each side. So there's no 3D printed parts other than these little hubs. You've got the bearings and stuff in there, and these are rock solid. This is the center foot even after being out on several events, and it really hasn't been cleaned up. So anyway, it really works. If you have the means, I definitely recommend going with the Vex Omni Wheels. They're just such a it's nice to have that peace of mind that you don't have to worry about these things breaking. So let's move on to the main drives. So when we start talking about the main drives, there are 5 essential modifications that I think are worth the time and investment. The first one here is, like the center foot, replacing the 3D printed ankle joint with a hardware solution. I documented my process of finding the best solution in my video. That's an overview of the Baddeley Mark III leg. I'll try and provide a link to that. But essentially what I use is, this is a 110 millimeter M12 socket cap partially threaded bolt that's been cut down to a length of about 80 millimeters. And the reason that I went with a longer bolt and cut it down is so that the unthreaded portion spans the pretty much most of the opening where the ankle is actually going to sit. I didn't want the ankle sitting on threads. The socket cap is important because you have that little curved notch in the foot shell, and a hex head bolt is really not going to fit. You'd have to remove some material there on that. But yeah, this is, in my mind, an absolute must-have on your droid. All right, moving over to the drive itself. As you can see, again, like the center leg, I'm using the Vex Robotics Omni Wheels. Again, these are just bulletproof. They're so much more durable. There is a difficulty right now. Supplies have been limited, and this hexagonal shaft that they sit on is a 1/2 inch, what they call Thunder Hex. That's been discontinued on the Vex Robotics website, but another Astromech user has contacted them, and their understanding is that it's only discontinued because they're changing their stock numbers. So hopefully before too long, the 1/2 inch Thunder Hex will be in stock again. In the meantime, they do offer 3/8 inch Thunder Hex, and they have 1/2 inch adapters. So that might be an option until that is available again. But definitely consider doing the Omni Wheel upgrade. All right, next we have 2 modifications that are available on the Patreon OneDrive. These were developed by Tim Hebel. I know he's very active on the Baddeley group, And he designed two parts that are a definite improvement over the originals. The first is an updated motor gear. This motor gear, well, here's the original motor gear. It's entirely 3D printed. It has a captive nut in there, and then this is your set screw onto the shaft. When I had my most recent event, I erroneously thought that both of my drive axles had broken. In fact, only one of them had broken. On the second drive, the problem that happened was my set screw on the motor gear had come loose, and so the shaft was turning, but nothing else was happening. So using these gears here allows you to use these metal flanges, and when you have the metal flanges, you can add something like Loctite on the set screw to really hold it in place on the shaft. Loctite will eat through most plastics, so you really can't use this on a 3D printed gear. But by improving this connection here, you're going to help ensure that that motor gear stays firmly affixed, and that would have definitely helped in my case. So by all means, replace your stock motor gears with these modifications from Tim. And then the second modification that Tim did was he created a modified version of the whatever this middle gear part is. So both of these broke on my drives. It's hard to tell for sure if they broke actually while it was being used, or if they simply broke while I was breaking things apart, because they fit together pretty tightly. But these actually go through the middle section of the drive and hold the middle gear in place. And what Tim designed was he designed this version, which if you compare with the original, it's got much larger surface area to support that, but it's also got the shaft is hollowed out so that it can accept an M3 bolt that can be threaded all the way through there, which will add additional strength to it. You do have to be careful when you're threading that bolt in. There's a narrow spot at this end, and so you'll be cutting threads. Tim suggests that you take one of the bearings and put that in place to provide support while you're driving that screw in so it doesn't split the shaft. But definitely do this, because these pieces are another weak link in the current design. And that brings us then to the final modification, and that is a replacement to the main drive axle. So you can see this one here is the drive axle that broke on my one drive. This is the one from the second drive that didn't break. Both of these parts are intended to basically fit into this slot here and hold the wheel in place, and then are secured in the back end. What I decided to do was take an approach similar to the center leg Omni Wheels and take an M8 threaded rod. I cut it down to length. I ground some flat surfaces there for set screws, and the intent is just to fix it on either end with collars. By using that piece, though, you are left with these little cavities where the 3D printed part would normally fit. So I've developed these little 3D printed inserts. I'll make these available on printables.com. They're really pretty simple. I did add some notches. They fit pretty securely into these little holes here. The notches are there so that you can flip the whole thing over. If you need to take these out for some reason, you can take a small screwdriver or a Allen key and push it out from the other side if you need to replace them. But these parts just fit in here. Just add a little bit of extra support and fill the gap. And with that in place, you'll have a much more reliable main drive axle, and you should be much better off. All right, so the drive has been fully reassembled. I also forgot to mention before that using the solid steel shaft for the drive axle really does make assembly a lot easier. This allows you to place the wheel in position and then slide the axle through, whereas before the axle was fitted into place and you had to slide the wheel down, and with the herringbone gears that made it a little bit difficult. So I think assembly is a whole lot easier with this approach. So anyway, we have the beefy hardware ankle bolt We have the solid steel shaft for the drive wheel. We also have the Vex Omni Wheels, and we have Tim's mod there for the gear pin, and then inside the motor gear is attached. The modified motor gear is attached to the motor, and I've got Loctite holding that securely into place. I did briefly toy with the idea of using a similar solid shaft and collars for the center gear mod, but when you go to assemble, or rather put the foot shell over the drive, there really isn't a whole lot of room for anything to be sticking out here. This lower profile modification is probably the best approach, so I'm going to stick with that for now. But hopefully these drives are a bit more robust and they'll be able to stand up to the wear and tear of future events. So anyway, I hope some of you find these modifications useful, and if I come across any other useful mods in the future, I'll be sure to add add note of them and maybe create a video. So good luck with your builds, and thanks for watching.